Hello.
Hello, good afternoon.
Good afternoon, yeah.
Selamat sore.
Selamat sore. So you know well about the Bahasa Indonesia.
Yeah, I enjoyed very much my work and stay in Indonesia. Yes, definitely.
So how many years ago?
Well, I left Indonesia in 2014.
Oh, okay. So how many years you
And
have
I
been?
worked between 2008 and 2014. I worked.
About 6 years.
Yeah. So
Okay.
it was a wonderful time. So how are you today?
Fine, thank you. Thank you for, well, you have many activities too, so it's very, we are very thank you for your time to have well, to give a speech about the France situation on nuclear power plant and in Europe.
And how is the situation?
Yes.
How is the situation in Indonesia? Sorry, I didn't have my video on. I hope, can you see me now?
Okay.
Yeah.
Yes, I can see you. Yeah, Indonesia right now, we are suffering the pandemic, the COVID-19.
Yeah, we saw it's quite dramatic, right?
Yeah, yes, that's why everybody has to work from home. The government have have policy to partially lock down for some part of Jakarta and other cities. So I have to work from my home almost every day.
Yeah, you know, in Europe we have been working from home for many months actually, and so it's.
Okay. So right now is normal right now? How about right?
Well, now we have what is it? The fourth wave already, Jean-Philippe? Is it the fourth wave? It is picking up a little bit again, but it's touching more younger people now because the let's say more elderly people are vaccinated, or many of them are vaccinated.
But almost everybody is already vaccinated, I think.
I think in France it's about 50% of the population, a little bit more maybe. Yeah.
Good numbers. I think Indonesia is still less than 20%, I think.
I see.
Yeah.
Yeah.
Well, good afternoon too. My name is Jean-Philippe Girard. And I hope you can see me, and the microphone is okay for the conference.
Yeah. There are so many.
Thank you again. Thank you again for inviting us.
Thank you for inviting us.
Yes, maybe I would like to try to put my slideshow on the screen just to.
Yes, wait. I have to make you as a co-host, please.
Otherwise, would you run the presentation, or shall we run it? How do you propose to organize ourselves?
Yes. It's free. If you want to operate by yourself, it's okay. If you want me to operate that PowerPoint, I will help you.
Okay. So Jean-Philippe, you will do it?
Yes, I prefer to do it just because I will have a PPT instead of the PDF, and just I'm trying to do it, see how it's working. So let's try. So
now try the slideshow.
So you'll see. I'm trying. Can you see it?
We can see it, but
yes, I can see it.
The PPT, try the slideshow now so that we see the slide in big. Full screen.
Yes. So I don't think it's working, at least from my side. I cannot see it.
If it doesn't work, in that case, maybe the PDF would be better, huh?
We'll do it. Vous êtes en train de partager.
Ça marche pas la slideshow?
Ouais. You know, sometimes you have different screen on your own screen and you don't know which one to touch. So now I am back on the conference screen. I think so.
But we still see your slides, huh? We still see your PowerPoint.
You can see my PowerPoint?
Yeah,
yes.
We see your PowerPoint, but not in the slideshow mode.
You just click that button.
Yeah, just to try the diaporama. Ça marche pas?
I would like to put it full screen. That's my question. That's it. Can you see it now?
Yeah, now it's okay.
Yeah,
now
it's okay.
Full screen.
Yeah.
Okay, full screen. So I will stop it and put it back, hopefully.
Yeah.
And put it back later. Okay? Because I think you will need to take the screen and so on.
Yeah. The moderator, it should be the ladies, Dr. Genirina, but suddenly she has something to do. So she cannot attend this meeting. So I will be the moderator for today's.
Okay.
Yeah.
So, okay, Pak Jarod.
Yeah. So I expect Pak Felipe Orang will participate.
Yes.
Yeah, he said he would. Yeah, he said he would.
Yeah,
I think so. Yeah.
So how is
you will start officially exactly at 4 p.m., right?
Yes, 4 p.m. I think we still have 7 minutes to go for to start the webinar. Then I will explain in Bahasa Indonesia, Indonesian language. Later on, we speak in a whole time using the English. But sometime I will translate the question from the participants. Maybe they want to use the Indonesian language into English.
Okay.
Yeah.
Okay, no problem.
So I understand you expect around 200 people for the conference?
Yeah. Usually, when we start about 70, then it will increase until more than 100. We divide into two tools using Zoom and YouTube. So some people use the YouTube, the other using the.
And Pak Jarod, you do this every month, or how frequently do you have
every
these
week?
webinars?
Every week. Every week. So
okay.
our activities, well, nuclear technology is very wide. Sometimes we talk about the nuclear energy, sometimes we talk about for the medicine, sometimes for the agriculture, many things. But sometimes we talk about politics also.
Yeah. Well, nuclear is very much related to politics.
Yeah, that's why it's very wide. We have the loyal audience that always participate in this webinar.
Just
every week, so that's a lot of work in terms of preparation and everything. Must keep you busy.
Just a last question. Yes. We expect the conference to be 1.5 hours overall. Do you expect 30 minutes question, 1 hour question. What is your expectation?
Yeah, okay. You may, it's very flexible.
Yes.
You may explain in 30 or 45, but we still have for the discussion, question and answer. Yeah,
okay,
at least 30 minutes.
Okay.
Okay.
Yeah.
Very good.
Yeah.
Okay.
Because the audience coming from in western part of Indonesia, middle and eastern part, sometimes we find difficulties to, well, they have different times.
Different time zones. Yes.
Yeah, time zone.
Okay.
Yeah. So how many minutes do you want to explain the presentation, Jean-Philippe?
I don't know exactly, because we will talk, both of us, and we can extend maybe to 45 minutes, and so we'll have time
So
for questions.
if it's okay, Pak Jarod, we will briefly introduce our company in the beginning, Nuke Advisor, and then we will Jean-Philippe will roll out the presentation, and then of course we are open to all questions, and maybe that's the most important part, to have a discussion.
Okay, thank you.
Yeah, I can see Philippe Rein has joined.
Oh, okay. Hello, Pak Philippe.
Hello, yeah. Yeah, okay.
Please unmute your microphone, Pak Philippe.
Yeah, okay. This is that unmuted. I don't know. Do you hear me?
Yes.
Okay.
Yes. Good afternoon.
Good afternoon, Jan.
Good to see you again. Huh?
So long time.
We met in Jakarta many years ago.
Yeah, long time. Oh. Yeah. Yeah. Happy to meet.
So how are you, Pak Philippe? Are you still in Jakarta, I think?
I'm okay, very good. No, I am in Bali now.
Oh.
I am at Bali from the coronavirus in Jakarta. Bali is less active. So especially I am in Ubud, so there is a lot of wind. So virus. Till now, I didn't get anything for the visa. But that,
I think you have a problem with the internet connection, I think.
Oh yeah, maybe. Yeah, that's why. Yeah, my internet connection in Bali is not very good. So maybe I will not raise question because the other day I was trying and nobody understand me. Shafla, listen to you. Okay.
Okay.
I'm sorry, but my connection is not enough.
Okay. Thank you. Well, still 1 minute. Saya akan memute Bapak Ibu sekalian mikrofonnya, kecuali yang kita minta untuk bicara ya. Okay. Good morning, good afternoon, good day, everybody. My name is Jarod Wisnugroto, just call me Jarod. I'm the moderator of this webinar. Unfortunately, Ibu Dr. Genirina Sunario could not attend this meeting because suddenly she has something to do that she cannot avoid. But later on, maybe she will join this webinar. Selamat siang, selamat sore, mungkin juga selamat pagi Bapak Ibu semuanya. Kita memasuki webinar ke-31. Webinar HIMNI ini sudah kita selenggarakan totalnya 63 selama pandemi. Jadi moga-moga kita harapkan pandemi selesai, tapi kita harapkan juga webinar ini tetap bisa berlangsung. Hari ini kita mengundang 2 orang pembicara dari Prancis yang kita minta untuk bercerita terkait bagaimana perkembangan Prancis dalam PLTN-nya, dalam hal bagaimana mereka sampai saat ini masih sebagai negara yang porsi PLTN-nya sangat dominan, lebih dari 70%. Mereka juga eksportir listrik dari nuklir ke negara-negara tetangga. Bagaimana situasinya di Eropa secara umum? Kadang-kadang Prancis itu dibandingkan dengan Jerman. Prancis punya PLTN, Jerman akan phase out atau akan menghentikan seluruh PLTN-nya pada tahun 2022. Kadang-kadang dibandingkan bahwasanya Prancis lebih bersih dari emisi gas buang, sementara Jerman lebih kotor. Nah, hari ini kita akan mendengar kaitan dengan perkembangan PLTN mereka dan energi nuklir di Eropa secara keseluruhan dari Pak Jean Bartak dan Pak Jean-Philippe Girard. Ini berkat saya harus mengucapkan terima kasih pada Pak Philippe Orang yang sudah lama bermukim di Indonesia, yang sudah menghubungkan HIMNI dengan 2 narasumber tersebut. Kaitan dengan Indonesia apa? Bahwasanya beberapa hari yang lalu di suatu seminar di BPPT, Menteri Energi dan Sumber Daya Mineral mengatakan kita akan harus mencapai target emisi bersih atau bebas dari emisi karbon tahun 2060. Dan nuklir akan masuk dalam bagian dari rencana itu pada tahun 2040. Itu mungkin berapa tahun? Masih 19 tahun dari sekarang, moga-moga kita masih hidup ya. Tapi sudah dimulai dipikirkan oleh pemerintah. Bahkan Pertamina pun sudah mempertimbangkan itu bagian dari bisnis mereka di masa depan, karena Pertamina sudah beralih ke bisnis energi. Nah, kami akan menggunakan bahasa Inggris dalam seluruh webinar ini. Jadi nanti kalau mau bertanya, silakan menggunakan chat atau pakai raise hand, pakai bahasa Indonesia boleh, bahasa Inggris boleh. Nanti saya akan membantu untuk menerjemahkan, menanyakan kepada kedua narasumber. Nah, sekali lagi, karena ini adalah suatu webinar HIMNI, kami mengajak kepada Bapak Ibu semuanya untuk juga menjadi anggota Himpunan Masyarakat Nuklir Indonesia. Saya akan berbicara pakai bahasa Inggris mulai dari sekarang. Good morning, good afternoon, and a good day, everybody. This is our 31st webinars, or totally we already conducted 63 webinars during the pandemic. Almost every week, almost every Thursday, we conduct the webinar. So we expect that the audience, the public knows well about the nuclear energy, nuclear technology, and we invite several speakers from politicians, the engineers, the scientists, and sometimes we ask from the parliament people to say something about this nuclear energy or nuclear technology. Today we have special speakers from France. First one is Pak Jean Bartak, because he knows well about Indonesia, so I can say Pak Jean Bartak. And the second is Mr. Jean-Philippe Girard. I'm sorry if I misspell your names, because I don't know French language.
Oh, it was perfect.
So they will talk about France, the development of nuclear energy, their status, maybe their challenge, in connection also with Europe as a whole. Sometimes in Indonesia, we always compare between the France and Germany. Germany will phase out from the nuclear energy next year, while France still maintain their nuclear energy. And France is very popular in us because the majority, the electricity or the energy coming from the nuclear energy. And what is the relation with us? Last week, I attend and I moderate webinars in the government webinars. One of the speakers is the Minister of Energy and Mineral Resources. He talked about the target of zero emission in 2060. And he talked that one of the options, not the last option, is to use the nuclear energy in 2040. And the another interesting one is the oil companies, the state-owned companies, called Pertamina. They say in the near future they will also involve in the nuclear energy business. So we have a good good expectation of that, but we still have many challenges, of course, to convince to the public, convince to the stakeholders about this nuclear energy. And let me tell you that we conducted public survey from 2010 until 2016, and in the last 3 years, from 2014 until 2016, more than 70% of the public, with the 4,000 respondents, say yes for nuclear. But anyway, we still have to convince for the energy business, like coal energy, key point persons, that maybe they are still reluctant to admit or to agree to build the nuclear power in Indonesia. And right now, Batan, the National Nuclear Energy Agency, they are conducting the visibility study in West Kalimantan, because West Kalimantan, they are suffering on the shortage of energy. They have to import the energy from Malaysia, the neighboring country. So the governor of West Kalimantan requests to the central government to conduct that visibility study. So this is my introductions, and also on behalf of Indonesian Nuclear Society, I would like to ask everybody, the Indonesian participant, to be the member of our society, so we can convince, if we can make this HIMNI, our Indonesian Nuclear Society, larger with many members, so we can convince to the president, to the parliament members, or other significant stakeholders. Nuclear energy is not the last option, but the realistic option for our future need of energy. But before we begin, the speaker to say something about with this thema, I would like to show you as usual, this promotion from the Indonesian Nuclear Society. Okay, let's first. I would like to introduce the first speaker, Pak Jean Varda, or Pak Jean. I can call him Pak Jean. He is the chairman of the board Nuke Advisor. Later on, I think he will explain what is Nuke Advisor, what is the correlation Nuke Advisor with the nuclear energy program. His background on the education MSc in nuclear engineering and PhD in thermal hydraulics. He have many experience in India, in Turkey, and also Thailand and Indonesia. So before we begin the webinar, he said he lived in Indonesia several years. So I expect he can also speak Bahasa Indonesia or something like that, about the culture and other things of Indonesia. Please, Pak Jean, the time is yours. Thank you.
Thank you very much, Pak Jarod. Selamat sore, everyone. Good afternoon. It's a real honor for us, for me and Jean-Philippe, to be able to talk to you today. So thank you to Pak Jarod and the Indonesian Nuclear Society for this invitation. And as you mentioned, it's a particular pleasure for me because, as you said, I spent several years in Indonesia. They were some of the most fruitful years of my career. And I had the luck and the chance and the opportunity to develop in Indonesia another source of low carbon electricity, which Indonesia is well endowed with, and that's geothermal energy. And I work with Pak Supramo Santosa and his company, Supreme Energy, is developing and already operating a new geothermal plant in Muara Labu, and another one is soon to be completed at Rantalera in Sumatra. So I was there setting up the partnership and doing the development of this project, and it was really very exciting and interesting years that I spent in your beautiful country. So I keep a very, very warm memory of those years. Today we will be speaking about what we can call today, from a historical perspective, already a success of the French nuclear program, because it has been a successful program. Of course, there are many questions open today, and we will talk about it. Actually, it will be Jean-Philippe who will do most of the talking. The difficulty we had while preparing this presentation was a little bit, we don't know very well the audience, so we expect that within the Nuclear Society there are many people who have real expertise and deep knowledge of nuclear energy in general, and in France in particular, because France is of course well known to all proponents of nuclear power as a country, having the highest share of its electricity production in the world coming from nuclear sources. But at the same time, we understood that there are people that don't necessarily have the nuclear background. So we have selected rather a more general and I would say higher level presentation. And we hope that you will have questions and we can go more in depth of certain aspects during the questions and answer session. So I think we can put on the presentation, Jean-Philippe. And I will, before we jump into the topic, as Pak Jarod mentioned, I will tell you a few words about Nuke Advisor. Let's just hope that we get the presentation on the screen.
Just please tell me if you can see the slides on the screen.
We can see it, but we don't see the slideshow. We see your PowerPoint.
And now?
Yes, now it's okay. Perfect.
Yeah.
Okay, very good. Maybe Jarod,
okay.
you want to still introduce?
Oh yeah,
me
yeah. Okay, I would like to introduce you first. Well, can I call you Jean-Philippe to make you familiar?
Okay, Philippe, it's easier. Philippe.
Okay, Jean-Philippe. Thank you. Jean-Philippe, he is the Nuke advisor, partner, and senior experts. So he is very experienced person, I think. He is the fluid mechanical engineer in the University of Grenoble, France. And he is also has many experience working, for example, in United Arab Emirates for the project of 4 NPP as licensing project manager in the Nuclear Regulatory Agency. It's very interesting, but and also she involved in the work for the Jordan built the GRTR, the reserve reactors that built by Korean vendor, and he also involved the Netherlands projects on the Argentine vendors for the reserve reactor also, and also in Bolivia, Saudi Arabia, and Argentina. Well, so many countries in Turkey, Tunisia, Ghana, Uganda. So this is very interesting that we can ask you many things about your experience also in many countries. But I would like to say that our audience right now is in Zoom 96 and in YouTube 35. Some of them they don't have a background on the engineering or scientists. They are general public that want to know about nuclear energy. That's why maybe their question is about what is the effect of Fukushima accident in France, for example. So please help me that you explain to avoid the too many technical words, for example, that's to make the audience knows the situation, the challenge of what is in France and in Europe. Please, John.
Thank you, Jarrod. Jarrod, ladies and gentlemen, thank you for giving us this opportunity to present this webinar on nuclear energy in France and Europe. And I will explain why France is so close to Europe in this presentation. So my name is Jean-Philippe Girard. Maybe some of you met me already in IA Vienna during some seminar. And again, good afternoon, everybody. I have a slideshow of 23 slides. So if you would have questions, please, you may refer to the number on the slides. It will be easier to answer your questions. And let's go for nuclear power in France and European policy and development. First of all, I will give shortly the floor to Jan to present who we are in Nuke Advisor. So it will be easier for you to ask questions on what we know. Maybe we don't know everything on nuclear, but then you will know what we can do. Jan?
Yes, so just in a few words, so Nuke Advisor is basically, we are a consultancy company, and it is somewhat specific and unique in some respect. It was established by a group of senior executives, I should rather say ex-senior executive from across the European nuclear industry, a lot from the French nuclear industry, like the French Atomic Energy Commission, the EDF, Electricité de France, or Framatome, the reactor vendor, but also from other countries like Belgium, Germany, and others. And the objective was to create a company that would be able to, let's say, capitalize on the experience and expertise that was accumulated in France over the years in terms of nuclear energy in the broad sense of the term, and to offer this expertise mostly internationally to countries that want to embark on nuclear, that want to develop nuclear power. So that was the vocation when Nuke Advisor was created about 12 years ago. And we still, I mean, our work is mostly in the international markets, working a lot with countries that are developing either new nuclear programs or research reactors and other activities in the nuclear power. We work also a lot for the European Commission. So we are a company where organized a little bit like a law firm, where I mean, we are the partners or partner experts are like partners in a law firm, working on the different projects and topics, and we have a small permanent team of kind of permanent staff of, I would say, younger, very bright engineers that help us implement the project. And we also have a network of about more than 100 subject matter experts that we can call upon for very technically, specific and deep expertise in different domains within the nuclear sector. So I think it's important to understand that we have at the same time the breadth. We cover the full value chain in terms of nuclear energy. And we also have the depth that with the expertise that we can call upon, we can go really very deep into different topics ranging from power plants siting and seismic issues through reactor technology, reactor physics, neutronics, across to waste management, fuel cycle, and decommissioning of power plants. So, and we also work a lot outside the power sector with the nuclear medicine and research reactors. So we are organized. So in this sense, we are very flexible, very reactive, no red tape, I would say. We can really react very quickly. And we are organized in 6 business lines that we cover. And you will see that we cover the whole value chain within nuclear power. So one is the nuclear program preparation. So this is what I said. To launch a nuclear program, that's a very comprehensive and complex task. I mean, developing any power project is complex, but in nuclear, the complexity is multiplied maybe by 10. So we support countries, institutions, companies that want to develop nuclear power. The other business line is we are very present in a kind of a niche market within the nuclear sector, which is nuclear research centers and research reactors, very specific sector, but also quite dynamic nowadays, because you may know that, I mean, research reactors are used in particular for the production of medical radioisotopes, which are extremely important and growing in importance worldwide. And the research reactors that were built around the world, mostly in the 60s, are aging and will be shut down. So there is a program in many countries of developing new and building new research reactors. We are very active in nuclear medicine, which is a very specific kind of area, but we have expertise within this area. Of course, as small modular reactors, a very, I would say, popular topic these days, very much discussed, and maybe there will be questions related to that. So we are quite active in this area as well. And then everything related to nuclear safety, physical protection, and non-proliferation, regulatory framework, licensing, and all these aspects. And the last part being waste management and decommissioning of nuclear power plants. So these are the 6 lines, and as you see, they cover the value chain within nuclear power. So that's just to give an overview how we are organized and who we are. So we are really focused in the nuclear sector. We are not active in other areas outside the nuclear sector. And I would just make a bit of marketing before I pass the floor to Jean-Philippe, because we are talking about Indonesia and let's say the emerging countries and countries embarking on nuclear power. I have recently written a newsletter which you can find on our website, which is dedicated specifically to the role that nuclear power can play and should play in emerging economies in order to decarbonize, making a clear argument that without nuclear power, deep decarbonization will be extremely difficult and challenging. So if you are interested, you can find the article. It was published in 3 parts, but all 3 parts are on our website, www.nukeadvisor.com. So that's to give you an idea of what is Nuke Advisor. And now I think we really need to jump into our topic. So I will pass the floor to Jean-Philippe, and maybe now and then I would complement, but we are looking forward to your questions on the presentation. Thank you, Jean-Philippe. The floor is yours.
Thank you, Jan. I understand microphone is working quite well, but we may have some connection issues. So please, Jarrod, you tell us if there is any problem. So the talk this afternoon will be divided in 2, France first, Europe second. And on the right side of the screen here, you can see the map of France. It's a strange hexagonal shape. And you have here all the main nuclear sites that were operated or are operated for electricity production and fuel and waste management. On this slide, all gray and red facilities are under operation. The other have been stopped. They are either on the Atlantic side of France, taking benefit of the sea as a water coolant, or on our main rivers. I will present what I call the roadmap for success. In some way, you know that IAEA developed this milestone document on how to progress implementing nuclear energy in a country. I will take the same shape of presentation, and also the future trends, as I will explain where we are and what we do now. The first thing to do is to compare France and your country, Indonesia. You are far bigger than us. You are 4 times bigger in size, 4 times bigger in inhabitants, population. We have very few islands, so the network is easy to organize in our hexagonal shaped country. It will be more difficult with your almost 220,000 island in Indonesia, of course. And we understand this is part of the trick also for you to develop nuclear. Our facilities have been installed in 17 sites where we have multiple units on different sites. I am calling it the roadmap for success, and I explain here the different stage of this development. Just after World War II, in the 1950s, we have what I call the early capacity building. I will explain who did it and how we did it. In the 60s, well, we start trainings on homemade design. We were quite successful in this phase, and we developed a concept with natural uranium and gas-cooled reactor. And but this was not the end of the story. So in the 70s, we made the right choice at the right time, taking a US design and putting it to the French standard. So in the last part of my slide, there is a standardized nuclear power plant running at full power here. So the core is on the left. It is a PWR here with the reactor vessel, control rod to control the reaction, a steam generator to taking benefit of the heated water and putting it in a turbine to produce in a generator electricity. You have containment structure, and then, of course, the cold source is either air and evaporation or a condenser with the sea or river water. I will not develop more what is the nuclear concept. I think you know, everybody, what it is. Now, I should push here, I think, yes. Let me go back one slide. So now it goes too fast. So how do we go backwards? How do we go backwards here? Precedent, yes. The capacity building phase, starting in the year 15, just after the war, was organized in a company, in a commission called the French Alternative Energy and Atomic Energy Commission. This is the name now. It is about now 20,000 researchers, and CEA, it is the official acronym, CEA, conducts fundamental and applied research in a broad range of disciplines, including, of course, nuclear reactors, medical and industrial radionuclides, safety, security, fuel, waste treatment. it is this organization that developed the so-called UNGG set of reactor, natural uranium graphite as moderator and gas. We developed almost 10 of those reactors, at first very small ones, and then up to 500 megawatts. We even sell one of those in Spain. But this was not the end of the story. We then realized that we needed a strong design and a new design, as was presented by mainly Westinghouse in the US. And in the 70s, we started developing 900 megawatt reactors, water-cooled, Westinghouse design, 3-loop types PWR. And we at first take exactly the Westinghouse design, then we update it to our own codes and standards. On the right side of the show here, you see the different years from 1970 to 2000. It is the vertical scale here. And on the horizontal one, all nuclear facilities that were developed in the 2 first stage of our program. In light blue, each vertical bar is represent when we start the program, when the facility was commissioned. First concrete to first electricity production. So the 32 first 900 units were built in almost 15 years, and each construction took, I bet here, from 5 years at the beginning of the program to 4 years at the end of the program. So it was a tremendous development, building 32 units in this time. And we took some design modification at first. And so we have three sets of 900 megawatts. The first one was called CP0, then CP1 and CP2. This was the first stage of development. And I can show on the next slide, excuse me, where is it now? On the next slide. It goes too fast using my, there it is. There we are. It is exactly the same slideshow, but I show on the right side the price of oil. And in fact, we had tremendous increase of the price of oil, as you can see on the right side. And we were lucky to have developed our program just at this time. So it gave us a tremendous opportunity to have constant price for electricity and being able to limit our impact on economy during this first oil crisis, I would say. So we are here on slide number 8. And so it was the first 20 years development of the 900 megawatt. I would like to say that most of these reactors are still under operation, except 2 of them. And the oldest one, which were on the side, on the east side of France, close to Germany, and which were closed last year. These were light blue, the 900 megawatt facilities. They were built on 1, 2, 3, 4, 5, 6, 7, 8, 9 different sites. So it's 32 facilities on 9 sites. Now, let's go to the next slide. No, not, yes, next slide. Is during the same time, we were successful being able to sell these concepts to 4 to 3 different countries. First in South Africa in 1984, 2 units were built in Coburg. It is up to now the only nuclear facility producing electricity in Africa. We may say that the second one will be hopefully Egypt, being having under construction nuclear facilities built by Russian. We also, a bit later, sold 2 units in Korea. They are still under operation. I visited them recently. And in China, we sold 4 units, 2 in Daya Bay and 2 in Linghao sites, which was quite a success. And you have a sketch of the facility here on the left. The main vessel in red, the 3 huge steam generator, the pressurizer, and the primary pumps here on the slideshow. What I can say on even the previous slide, because it's important for the balance of CO2 now, is that during this initial stage of development, we had slightly overestimate our needs. And so we shift thermal heating, for instance, to electric heating. So everybody was very happy to have cheap heaters coming from electricity. And this shift is very important because even now, a significant part of heating the houses are done with electricity, and it took the place of coal, fuel, and it is a significant impact on our CO2 production now.
If I may, Jean-Philippe, just I would add one point here. If you look at the rate of commissioning of the reactors, I mean, it is a rate that has so far never been achieved anywhere else in the world. Even now in China, where we see a very rapid development of new nuclear power plants, this rate of building and commissioning the plants, you can see that, for example, in a single year, there were sometimes 4 up to 6 units that were commissioned within a single year. This is really a tremendous development pace. And sometimes we hear the kind of critics that nuclear power plants are too long to build. Yeah, indeed, and we will talk about it. There are difficulties with the new generation of plants, but when they are built in series and you know, with a really industrial approach, you can organize the industry and everything to build and commission quickly, and we can see that happening to a large extent in China today. Yeah, please, just this comment.
Yes, I would say it may be interesting for you. As a result, the price of electricity here is around 10 cents a kilowatt hour on our bills here. So it's quite cheap. Without tax, of course, because if you take into account tax, it means nothing. So I am going back to export, and on this first 900 megawatt design, we took it from the US specification, and the US specification was 0.2 G for earthquake, so which is rather small, I would say. And for France and for some clients like South Africa, we had to develop a specific concept where the whole facility is built on aseismic pads in such a way that we don't have to re-qualify all equipment for higher earthquake acceleration. And you have here a presentation of this. This was done once in France, where a set of 2 facilities, which is 300,000 tons, was put on a set of aseismic pads. You can see this in the middle of the slide. And you have the drawing of how the aseismic pads are designed and implemented in the facility on the left side. It's also almost the same design for the French facility Cruas and the South African facility Coburg. Maybe you will have questions on this topic. We will come back on this a bit later. So now the adventures goes on, the beat goes on, as we could say. And in the second part of our program, we developed 24 reactors, 4-loop types PWR, bigger ones. So they were 1,300 megawatts and 1,450 megawatt, electric megawatt, of course, developed starting late 1970s up to the last one commissioned close to 2000. So it's once more 24 reactors. As Jan said earlier, the commissioning rate was a bit slower, but nevertheless, you can see that almost all the P4 reactors were developed together. Construction was ongoing together on all units. And we can see also an interesting lesson learned from this program. The industry at first for the smaller reactors in year 1970 was maybe more integrated in between designer, manufacturer, commissioning team, and so on. And so we were quite efficient in terms of time between first concrete and first megawatt. But for the last set of reactors, the 1450 megawatt, you see that the first one was rather long. We had difficulties to start a new design and commission it rather quickly. And we will see that this also impact our last design EPR that I will present in the next slide. So 1990 to 2000, 24 reactor, 4 loops. It's interesting to see that a 1400 megawatt reactor by that time was a 4-loop. And we know that other design around the world now are using the same, producing the same power with only 2 steam generators for some of them. So adventures goes on, and we go on this this program was stopped, and we developed a new concept. We may say that all these reactors were Gen 2, Gen 3. If you know what Gen means, it's an international program of development of design for reactors. And we developed a Gen 3+ concept called EPR. At first, E stands for Europe, and at the end of the story, it stands for Evolutionary Power Reactor. The EPR is a 1650 megawatts, so it's even bigger. And it was developed with an objective of reducing the core damage frequency to 10⁻⁶ per year or so, improve redundancy, improve design versus aircraft crash, and also improve a tricky problem is what would happen if we would have a core melt. In most of the design, you have here the reactor design on the right side of the screen. If the core will melt, it may go through the main vessel, as it did in some of main accidents around the world. I'm thinking of Chernobyl, of course. And designers have difficulties to imagine a design that will prevent the core to go further down. And in the EPR concept, there is what is called a core catcher. Some people call it an ashtray. So in some way, if the core will melt in the EPR concept, then the core will leak into a spreading compartment that you can see on the left side of the drawing. I visited this structure. I can tell you that it is a huge structure for a major accident, of course, that of course we don't expect to happen in this design. I may say that I think it is the only design in the world with such a spreading compartment in case the core will melt. You may have questions on this topic and you will ask later. This is slide number 12. So let's go to now this Gen 3 concept, EPR. We have 2 EPR in operation in China. Maybe you've seen press release on this, recent press release on this EPR. I will answer question if there is any. We have 4 units under construction, 1 in France, 1 in Finland, and 2 in UK. And we have further opportunities in UK, 2 units, India under discussion, 6 units, and other Eastern countries, Eastern Europe countries, such as Poland or Czech Republic, under discussion. We have lost the opportunity to develop the EPR in US, even though we went through licensing and so on, or pre-licensing. And we have lost the contract in United Arab Emirates, where the Korean were, may say, cheaper, and maybe they arrive with a technical but also a financial proposal that suits more the expectation of Abu Dhabi. So I think now I will go to the fuel cycle and few words on safety before we go to Europe. France has decided very early in the program to go to a closed cycle. What is a closed cycle? It means all spent fuel, all UO2 spent fuel was reprocessed, is reprocessed, and reprocessing it allows to take benefit of the still existing fissile uranium in the fuel and the plutonium that is built up by the fission by the reaction, and providing thus the opportunity to manufacture a mixed oxide fuel between uranium and plutonium, and using it again in the nuclear power plant. So you have here the performance of the system. Every year we manage 1,000 tons of spent fuel, and we recover the uranium and the plutonium to reuse it. And so we reduce, first of all, the high level waste. And secondly, as a result of this, since the beginning, we've been reprocessing 23,000 tons of spent fuel, which is equal to the needs of 14 years of electric production in France. And this making a significant contribution to the country energy independence, even though we know that now uranium is quite cheap all over the world. On the right side, you have again this map of France, and the 2 main areas where fuel is reprocessed and waste are managed is a side close to the Atlantic side or to the UK side of France, which is called La Hague, where there is the reprocessing plant. And on the east side of France, you have all the storage facilities for the different kind of waste we have. So now let's go where we are, where we go. We are slide 14, okay. On the next slide, yes, I put safety at the end. So the future of nuclear energy in France, maybe also in the world in some way, is trying to build up from the EPR on maybe a slightly cheaper concept, and building up a series of EPR. It's called EPR2. It will be for the French market. We will have also a smaller EPR called EPR 1200. It's a 3-loop PWR, for the export market. We had pre-licensed 1,000 megawatt concept with Japan. It was called ATMEA. Was proposed in some countries, but we were not fully successful, I would say. We have, and this may be an interesting point for Indonesia, studies being performed either on the concept as we do, and we will see our publication, but also as design. There is a French concept called French design called New World. It's I would say it's a 300 megawatt SMR, PWR type. It's quite standard. And we, Nuclear Advisor, participate to an interesting adventure, I would say, the synergy concept, which was, you can see the drawing on the left side of the slide here. It's a submarine SMS in some way. You bring the SMR to the site on a boat, and then you operate it underwater, which in some way allows you to remove the concrete in the concept. I'm sure you will have questions on SMR, so I will leave the floor open on this topic. And of course, even though it's not fission, but we were lucky to invite and successfully, France was selected to develop a fusion reactor, the ITER project, which is an international project with China, Japan, Korea, India, USA, Europe, and Russia. And this facility is a 500 megawatt test facility. And I put it Q10 here because these 500 megawatts are produced out of 50 megawatts. I will not develop this concept here, except if there is questions. It's an international project and it's under construction south of France with expected first plasma in 2030 or something like this. There we are. And we go to maybe the last slide on France, safety and licensing. There is a specific aspect on safety and licensing in France. We have one operator, or at least up to now, we have one operator. Of course, we have one regulator, and we have one TSO, technical support organization, or one main technical support organization. The licensing aspects in France, it's a two-step standard licensing process, construction and operation. You know that some countries like NRC, US NRC start developing a one-step licensing, but this has not been implemented in France yet. We have every 10 years a safety reassessment. Our regulations are mostly non-prescriptive, which is easier to operate when we have only one operator. And the overall system is also supported by an advisory group called for every NPP major milestone. I was myself a member of this group. So safety and licensing, if you have any question, you would ask. And as the last slide for France, I can say a few words on our energy policy in the next coming years. On the screen here, you have the electricity production by source from 2000 to 2020. So you see that the pink area in the middle, it's nuclear. So nuclear stands for 75% of the production. On the screen here, you can see the 2008 crisis with a decrease in the middle of the slide, and also the pandemic aspect at the end with a slight decrease. Of course, the second source used in France here is a green source in some way. It's hydropower. which is quite significant since the beginning, because it has not changed a lot because we have equipped all our sites in hydro. And then you can see the wind, solar, and other renewable on the top, and the oil, gas, and coal on the bottom part. I will discuss for Europe the intermittent aspects, of course, of some of these renewable. We have a strange objective in France. Not everybody is understanding it, but this is a political decision, as said at the beginning of the talk. The objective is no more than 50 nuclear after 2035. We don't exactly know why, but it seems that for political reason and electoral aspects, nuclear should be decreased in the next 15 years. This is it for the last talk on the French energy policy. I'm going now to Europe. So Europe is a unique electric network with France. So everything I said on France earlier is only one part of the electric network in Europe. And of course, if we speak of Europe, Europe will take benefit of the 75% electricity in France in the balance of CO2 for Europe. So there is one network with 500 million customers, 700 gigawatts production capacity, it's a capacity, and of course, a capacity of about 100 gigawatt NPPs. The electricity generation in the whole network, you see this network is also connected by some aspect to Africa and to the Middle East. But it's almost 3,000 terawatt hour production. It's 35% fossil fuel, 25 nuclear, 12 hydro, and 26 wind and solar. And again, the 26 wind and solar looks very good like this, but it's only when we have wind and sun available in Europe. So a huge network, I would say a network that is going further than political aspects, and it's only a technical burden, I would say. You see a lot of connection with England, even though the Europe is 50 hertz, yes, UK is still 60 hertz. So you have a strange converter in between both systems. The electricity production in Europe is on this slide, with on the left, the overall electricity production, where you can see that nuclear is 25%. Fuel, gas, petroleum, solid fuel is about half of it, and renewable is about 1/3. About this 1/3, 1/3 of the renewable is hydro, wind is 1/3, and the others are solar and bioenergy. Bioenergy is very interesting because it is an opportunity for farmers who were in difficulties to proceed with their production to be now engineers. I have a cousin who was very poor but has a lot of land, and he went to bioenergy. So now he's producing 1 megawatt full-time, full year, and he's very happy being able to stay in his farm north of Europe. On this slide on the right, you can see that the intermittent energy are wind, solar, and solar thermal, and solar photovoltaic, and tide, waves, and ocean also. And we know that this part of the renewable, intermittent renewable, cannot grow too far, because at one point, as you almost need to have available a fixed possibility to produce the electricity, a base load possibility, then you cannot go to wind too far, except if you can store. But if you can store, it's a good trick. You can store maybe in hydrogen, but it's very expensive, and in some way, no need to store wind in hydrogen if you can produce electricity directly from nuclear and cheaper. So this is the balance for Europe electricity production. And on one of these last slide here, I put the results as a whole for all energy production in Europe. On the left side, CO2 production per capita. And on the right side, per GPD. So the strange thing is that I don't have the unit anymore, but forget about the unit. On the right side, it's a GPD per capita. It is per GDP, excuse me. The scale being EU 27, the European Union 27 countries working with an agreement, is put at 100, and on the left side, it's per capita. So on this slide, we could talk for 2 hours or perform a PhD thesis. Of course, we have impact of the size of the country, because the bigger the size, the bigger you will need petroleum for transportation. Of course, in different countries, you have different temperature in the winter, and then you may need oil or gas to heat your country. Of course, these countries have different level of development, and all this impact the results. I just will show some example. France with nuclear as a whole, even taking all uses of energy sources, is quite good per capita and per GPD because of the nuclear, of course, and because of conversion of heating from oil and gas to and coal to electricity. We can see that Sweden is in the same mood, I would say, same result per capita and per GPD on the right side. We have other countries with dams, like Switzerland. So Switzerland is quite good per capita and per GDP. And why? Because even though they have a small country also, but they have a lot of dams, and also they have a lot of isolation of their house. So they are quite efficient in using the energy, which may be not the case of other countries. So we will come back to this if you want later. My last comment would be Germany. So as you said, Jarrett, at the beginning, you're looking at France and Germany. So France has a lot of nuclear and few wind farms, and with quite good result. Germany has a huge amount of wind farms, but of course, when there is no wind, they need to burn coal or to burn fuel or to burn gas. So their result per capita is not so good, and their result per GDP is not below the mean target of Europe. So keep in mind this slide if you have any other question, or maybe you will bring more comments from your side on this slide. Please do at the end of the talk. And now you ask, what is the European Union? I mean, the 27 countries working under an agreement for their energy policy. Well, they have developed a concept to reduce their CO2 production by the next 10 or 15 years. And unfortunately, in their policy, there is not one word on nuclear electricity production. It's something we don't understand. It's a political aspect also of the 27 members of the European Union. There is a long discussion on what is the green energy, or we call it green taxonomy, and should nuclear be included? as we understand, nuclear will be included if gas is included, because gas is pollute less in CO2 than coal, but as you may imagine, gas is a CO2 producer anyway. So in this European Union, we have 106 nuclear power reactors, nevertheless, so 100 gigawatt electric capacity in 13 of the 27 member states. And it is 1/4 of the electricity generation, and it is 12.5% of the total energy production. And some countries are pro-nuclear, some are not. And you see the pro-nuclear countries here in EU: France, Finland, Poland, Czech Republic, Bulgaria, Romania, Slovenia, Slovakia, Hungary, the Netherlands and Estonia, and others have almost decided to stop their nuclear program. So there is not a clear energy policy shared by all members of the European Union. Now, last slide, a bit complement of the previous one. So generally speaking, we see that UK is starting a huge nuclear program. The old Western Europe is slowing down its program. The previous Eastern Europe is developing. And some countries are quite happy with renewable, like dams, for instance, or wind. And again, the result for the overall energy production, 12 for the nuclear in the whole Europe, and 37 for oil and gas. So you see, we are far from being zero CO2 production in Europe because of the need of industry, the need of transport, the need of eating, and so on. And that's it in some way. So thank you very much. And if you have any questions, please do. I don't speak Indonesian, but I imagine this means thank you or please ask questions. So go ahead, Jared, you have the floor.
Thank you. Thank you very much, Jean-Philippe. It's very interesting, especially when we talk about this categorization of pro and not pro-nuclear in European countries. There are many questions. So many questions ranging from about, well, the policy, about the anti-nuclear, about the nuclear weapons, about the generation for the price of electricity. But first, I would like to mention for everyone, more than 450 audience, Zoom and YouTube. It's very interesting one. So you are very popular among us about this theme is very interesting. I will talk about first about the reprocessing. Maybe the audience should know in bahasa Indonesia. Bapak Ibu sekalian, Prancis adalah negara yang menerapkan siklus tertutup. Jadi bahan bakar nuklir bekasnya, spent nuclear fuel-nya itu diambil uranium dan plutonium untuk dipakai kembali. Itu menggunakan teknologi reprocessing, meskipun itu adalah teknologi sensitif karena punya potensi untuk menjadi untuk kegiatan senjata nuklir. Tapi ini perlu saya sampaikan. I would like to explain about that because some people ask us about the radioactive waste. How about the reprocessing? France has a capability and have a specialty on the whole nuclear fuel cycle.
Correct.
Yeah. So this is, I want to explain in Bahasa, well, I have already explained in Bahasa Indonesia. And the first questions from the audience about why, maybe this is the mindset of Indonesia. Why do French people support the nuclear? Is there any, or are there any anti-nuclear movements? Or maybe you may show us about the public survey, recent public survey, or the latest public survey about the opinion of the public in France, please. Whether Jean or Jean-Philippe.
Yeah, I will try to answer. It's not easy to answer. Well, the program was developed in the 1970s, where we realized we had no coal, or coal was very expensive. We had no oil, we had very few gas, and so we decided to start a nuclear program. And by that time, it was not a problem from the political aspect, we may say. And so we developed the program, and so the program is here. Now I would like to say, people are happy because they have a cheap electricity, but green people are coming and are more and more in the political arena. And that's why also we have this goal to reduce the nuclear program without major goal, because either you have nuclear or you don't have nuclear. Having half of the nuclear maybe limit the risk by a factor 2, but means nothing in some way. So be sure that in the past, there was a silent development of nuclear. Everybody is happy with it, but some of them, I would say maybe 25%, may say that nuclear is no good because of Chernobyl, because Fukushima, because so and so, because, you know, Fukushima, people think that all the problem come from the nuclear. In fact, all the problem come from, the main problem come from the tsunami and not the nuclear. So I'm sure you have the same discussion in your country because you are subjected to tsunami also. So.
Yeah, I would just add to what Jean-Philippe said. You know, I don't. You should not, let's say, believe or understand that in France or in Europe, even more so, there is kind of general unanimous support for nuclear. That's not the case, and this is where your society and us and many others, of course, are working to share the facts. It's the facts that we need to use, the reality of the situation, and of course, with the climate change becoming a major issue, the mindsets of people are shifting. So as Jean-Philippe said, in the 70s, 80s, it was not really an issue. You know, it was the technological development which was kind of attractive, and people were not so much concerned. But yeah, unfortunately, we had accidents which have been again miscommunicated in the media by politicians. You know, if you look at the real numbers, at the real facts, and you look at it, if you look at all sources of generation of electricity, including renewables, and if you look at the number of casualties per, let's say, 1 terawatt hour produced, nuclear is by far the best, even if you include the nuclear accidents. You know, you hear every month in the news that there was a problem in a coal mine. People are dying of pollution from coal plants and so on and so forth. I mean, the numbers are orders of magnitude different. There are more people falling from the roofs installing solar panels, or falling from the mass of windmills. But you know, this is not reported in the media. Any single incident, even a small one on a nuclear power plant, is bloated by the media. This is a problem. And in France, of course, it's, I would say, more or less half-half, but the support for nuclear is increasing in the recent years because of climate change issues. People are becoming more and more aware that there is no other way out, that, you know, 100% intermittent renewables is not going to work. It just doesn't work, and Germany is a great example. So people understand, and there was recently a poll in France, and I think in France it's about 59% of the population is in support of nuclear power. But again, as a result of, you know, years of misinformation, there are more than 2/3, around 70% of people, and in majority young people, that think that nuclear power plants are emitting CO2.
Oh.
Because they show you the cooling towers, you know, with the steam coming out, and 70%, can you believe it? Of people believe that nuclear power plants are emitting CO2. So this shows the level of misinformation, of a lack of education at schools, you know, media, of course, which makes it difficult. Now, you know, we would spend hours in trying to understand why all this has happened. It's a kind of a general trend. But what we believe, it is really the climate change imperative that is again putting nuclear power under a new light. And of course, many wonderful associations and societies and companies and so on and so forth are doing a lot to promote nuclear power. But even within Europe, it's it's still dividing the countries. You know, we are 27, and you have about half of the countries that are pro-nuclear, and another half that are either neutral or anti-nuclear. And it makes any consensus very difficult, because in Europe everything is based on consensus. You know, everyone has to agree. So it's a kind of a lowest common denominator that comes out. And because Germany is a very powerful country in Europe, and it is today opposed to nuclear, it's very difficult for the others to push it forward. But fortunately, in Europe, we have a policy principle which says that at the European level, they would only, let's say, declare objectives in terms of carbon emissions and things like that. But every country has the right to decide on its own electricity mix how to achieve the objective. So this leaves some ground for countries like France, or the countries that were listed on the slide that Jean-Philippe has shown, which are pro-nuclear and that want to develop more nuclear power, because they simply understand that without that, they will never reach the objective of bringing the emissions down by 55% for 2030. That's the objective of Europe. You know, countries that don't have large hydro resources, they don't have too many wind resources, and in the Northern Europe, not so much sun. You know, there is no way, there is just no way. Otherwise, you will rely on gas in the end. And this is what is happening. And, you know, we have done at Nuclear Advisors some calculations, and even in Germany, if they phase out nuclear and they replace, even after they phase out all coal, they will still have to have a number of gas power plants, and they will never, even ultimately, they will never get below roughly 200 grams of CO2 per kilowatt hour, whereas France today is below 30. So, you know, so there will still be a factor 10 difference. Without nuclear, you will never get there. Of course, they say, the gas, there will be some green gas and biogas and hydrogen. But, you know, number one, how do you get it? You know, you still need electricity to produce it. So it's a complex discussion. But without nuclear power, hoping to have something close to zero emissions in the electricity sector, I'm speaking only about the electricity sector, it's virtually impossible.
Okay.
Sorry, I was maybe a bit too long.
Yeah, no, don't worry. It's very, very interesting, because the audience, the Indonesian, want to know the situation, the background, why the French government or the French people still use dominantly the nuclear energy, because maybe there is a different mindset. The French people already get benefit from the nuclear energy, while we don't. We haven't not yet. Yeah. So this is different. So the question is, do you believe, some people in Europe believe that renewable is the solution for the, zero emission? How about your opinion? I think Jean already mentioned or answered short of. Some people believe, whoa, we can use all of them using the hydro, wind, and solar. How about your opinion about that?
Yeah, you know, I think definitely we need renewables if we want to get out of fossil fuels, because the objective is to get out of fossil fuels. So what do we have? So, you know, what are the options? You have hydro. I think all the tidal and all that, we can leave it aside, because it's kind of still very speculative and very, I mean, it will take a long time to develop that at an industrial level. So there is no one fits all solution. You need to look at the situation of each and every country or region. Yeah. Look at Norway. Norway is a good example. You know, Norway doesn't need any nuclear power. They don't even need any solar, or they have so much hydro. Okay. That, you know, and what is Norway doing? When they are selling hydro to actually, to put it this way, there is a lot of wind in northern Germany and in Denmark. So when there is a lot of wind, electricity in Europe drops to zero, the price, or even below zero, it's negative. So Norway will buy or will get paid to get all this electricity, and they use it to pump the water up in their hydro plants. And when there is less wind, and for example, in winter in Europe, in the evening, the days are short. So at 4 p.m. there is no more sun. And if there is no wind, and this usually happens when there is a cold spell, because it's anticyclonic, so there is no wind and it's very cold. So consumption jumps up. So in this case, Norway would be opening all the valves and selling expensively the hydroelectricity to Denmark and to northern Germany, because they need it. So Sweden, similar. Sweden combines hydro with nuclear, and they have one of the lowest per kilowatt hour emissions in Europe. It's Norway, Sweden, France, and Switzerland. These 4 countries are the best in Europe. Why? Because they have hydro and or nuclear. There's no secret. So okay. To get back to renewables, of course we need them, but they are almost invisible when they represent a small percentage on the grid. But once they represent a significant percentage on the grid, you start to have problems, because you have situations where you have too much wind and too much sun and you don't know what to do with it. So in a way, you have more capacity than you need, and the prices are dropping down. But when there is no wind or no sun, you still need electricity. So you must keep the backup. And Germany is an excellent example, because if you look at Germany 20 years ago and Germany today, you have in Germany 2 electricity systems with roughly the same capacity. The capacity of their fossil plants has almost, we could say, not changed. It's still there. Of course, they are used less. So in terms of emissions, it is better, because in those days they were used all the time. Now they are used less, but they are sitting there and they have to be ready. And the second system is a renewable system, which has actually even more capacity. So when there is a lot of wind, there is too much electricity in Europe. Nobody knows what to do with it. And this is why prices are dropping down or even becoming negative. But because it is subsidized, the producers don't care, because they are paid anyway. Mm-hmm. But the point is that you need to keep the original fossil system, and sometimes you need to keep the plants even heated up and ready to produce. That means you are still burning some coal or gas, because your turbine has to be hot and ready to increase power very quickly in case there is a drop in wind or in the evening when there is no more sun. And this will never disappear, even if you have all the renewables. This will never disappear. Again, you need to look at different countries. It might be different in different countries. For example, in the Middle East, where there is so much sun, but still the sun goes down in the evening, right? So and people come home from work, and they want the air conditioning to be on, and even in the evening. So you need something. This is a big problem in California, where you have a lot of solar, but people consume a lot in the evening, and there is a very steep curve of when the sun goes down, consumption goes up, and where do you get it? So you need to keep the backup. And what can provide the backup if you want to get out of fossil fuels? Only nuclear. There's nothing else. Or fossil, or gas, or coal, or of course that. But in that case, you will never decarbonize. So this is, if the objective is really to get out of fossil fuels, we don't think that it is achievable without nuclear power.
Okay. Well, very interesting. There are some questions about radioactive waste. France used the reprocessing. So the NPP will always generate the high level waste. How can you manage that waste? There's one question. Another question is, how can you get the uranium? Do you import from outside? Then you fabricate that for fuel? This is the second questions. The third questions concerning about the earthquakes. we are living in the a ring of fire in some parts, but we have in Kalimantan or in other islands almost the earthquake or tsunami is the possibility is very low. How about France? This is the third questions. The first one, radioactive waste management. The second, how do you get the uranium? And the third one about the earthquake. Please.
Jean-Philippe, you take up this one.
I will try to answer to these questions. The easiest one is where is the uranium coming from?
Yeah.
So we have some mine in France, but operating these mines will cost more than buying uranium from abroad. At least of uranium ore is rather cheap. So we have contracts with some African countries, for instance, to import the uranium. And so it's not a problem now to get uranium cheap all over the world, now at least. The second question about waste. So there is a very strict categorization of waste in France. And we have a very specific rules also. Everything that will be bring in a potentially contaminated area will be put in a specific storage. So there is nothing coming from a nuclear facility that will be bring back in the open market. So then we sort the waste, and we have very low waste storage facility, low wage storage facility, and these facilities are under operation. And we have a lab under operation in order to develop a storage for high irradiated waste or actinides and stuff like this. A long discussion on shall this storage be reversible, meaning shall we put it forever or will it be possible to go back and get it back? Of course, it may be easier for a security reason to put it forever, but people think that maybe we will have better processing in the future, so it will be better to be able to get it back. So this is the discussion now. So this is the second question. We have the storage, the disposal facility available, either for all kind of waste or under development for the highest stuff. The fission products are put under glass, and they are stored until in pool until they will be stored underground. The last question is about earthquake. Yes, in France we have a rather low level of earthquake, but remember that the drawing I show of the world map of earthquake on one of the slides is the level for everybody, everyday life. This is the 500-year return period map. And for nuclear facility, you have to take into account a 10,000-year return period level, which is called the SL2 level in the US regulation. And yes, in some part of France, we may be slightly higher than 0.2 G. That's why we have this concept. And of course, Japanese people are very wise also about earthquake. But we developed this concept of aseismic pads to be able to implement standardized design of 0.2 G on an aseismic set of pads.
If I may add just one point on the question on waste that people sometimes don't really realize, and that is the point that the volume of radioactive waste, especially in the case of France where we reprocess the waste, is extremely small compared to any other type of waste. So just to give you an image, the level of high-level waste, which is the high-level radioactive waste, which is the one that is let's say dangerous and long-lived, in France per capita per year is about the volume of the tip of my finger. Okay, So this is the volume of high level radioactive waste that would be generated. So you will understand that it is not such a great issue to keep this waste stored safely. Of course, it is put in kind of vitrified and protected and surveyed and all that. So it is not such a big issue, you know. I mean, the issue is being really again blown up by anti-nuclear movement. But maybe you can tell me if you ever heard that anyone has died because of exposure to radioactive waste. I have never heard that happen anywhere. So you know, it is a technical issue for which there are technical solutions which exist. And you know, when people say, yeah, but it will be very long and you know, so many years and hundreds of years. Well, you know, if we believe that civilization will evolve, they should be better than us in knowing how to deal with it. And if we don't evolve, well, maybe it doesn't matter so much.
Okay. There are three last questions. It's already 5:30 right now, 5:30 p.m. The first one about the SMR. Jean-Philippe, you mentioned about FlexBlue, the subsea NPP. Several years ago, they came to Indonesia to promote the FlexBlue.
Yes.
Yeah, FlexBlue is very interesting. France had an experience on their submarine for the military purpose, but they want to use as for the peaceful use for the FlexBlue. How is the status right now? This is my first. And the second, several persons asked about the molten salt reactors to use the thorium as the fuel for the molten salt reactor. Is there any program in France about that molten salt reactor using thorium? The third one, some people also interest on the fusion. I think Jean-Philippe has already involved on the ITER program. So how is the status right now? Is there any roadmap for the future to commercialize that fusion reactors? That's three, please.
Okay, I will answer to 1 and 3 maybe, and leaving 2 to Jan. Well, FlexBlue, we worked with the people who were developing the submarine engine in some way, and we have a pre-design. I would say, unfortunately, having done this, the decision in France was to provide budget for a larger and more standardized SMR. So we have the experience, and this is quite interesting because to develop other or to survey other projects, it gives us some skills in some way. So, but it is on hold, I would say. We know that the Russians have developed a 35 or 50 megawatt floating facility. We know also that bringing such facility outside of your home sea may be a specific issue, even though we have some boats doing this, but this is it. On the fusion project, it is an international project. It is under development in France for the ITER project. We know that there is at least 2 other or 3 other projects underway. One to improve and specify the materials that will be submitted to a very high doses of neutrons in these facilities. And there is another program which is called DEMO. The objective of DEMO is being able to demonstrate that electricity production is possible with fusion. We understand that these programs will be for the future. They will not be for the 2035 or 2050 objective of CO2 reduction. But it's always interesting to keep on research on this topic. But it is not for the midterm electricity production.
Not for the midterm electricity production.
Yes.
Yeah.
Yes. Jan, you want to answer on the SMR?
Yeah, okay. A few words on the molten salt reactors. Well, I'm personally a big fan of molten salt reactors. I think they are offering really some very interesting, let's say, features in terms of disruptive. I would call it really disruptive innovation or a kind of paradigm change offered to, let's say, in the way nuclear reactors are operated, because the fuel is fluid in a molten salt. So it offers a lot of opportunities to operate. You operate at low pressures, so you don't have all the issues that we have in pressurized reactors in terms of safety. They are intrinsically safe, I mean physically safe. So there are many attractive features, and I know that one of the companies developing them, Thorcon, the American company, is very active in Indonesia. They're trying to promote the concept in Indonesia, and indeed the solution that they offer, I think, would be very well suited to Indonesia. So I'm quite enthusiastic about them. At the same time, we have to be pragmatic. So to speak about France, there is research ongoing in France, but there is no, I would say, advanced development. There is some research even funded by the European Commission, and in France, until recently, it was not a major topic. France was much more focused, of course, on PWRs, but then on fast reactors, fast sodium-cooled reactors. But recently, within the CA, the organization, the research organization that Jean-Philippe described, there is a team that has been set up now that is looking more in depth into molten salt reactors, specifically for the reasons that I explained, that they are really offering a disruptive innovation, bringing very high levels of safety, very flexible, capable to respond to the grid very quickly, so they can fit very well with renewables, where you have changes in demand that are very frequent. So they have really many attractive features. On the other hand, they are still very new. I think the licensing process will be complex because the regulators are not used to them. It's a completely different approach. So I think it will still take some time. That's my view.
Okay.
But definitely it's a concept that is being pursued by several developers, and some of them got even important funds recently in the US, for example, Terrestrial Energy, developing a molten salt reactor. So yeah, let's hope this goes forward. Now, if we speak about SMRs in general, if we say that there will be the first SMRs in the next decade, I'm not sure that the MSRs, the molten salt reactors, will make it in the next decade, specifically because of licensing issues and a lot of R&D to confirm and qualify things, and then equipment and materials.
Okay, thank you very much. Thank you for your opinion about the molten salt reactor. So we have already passed the time, more than 1 hour, and we are still many participants. I would like to close this webinars by invite Jean and Jean-Philippe your closing remarks about is there any possibilities the cooperation between Indonesia and France on the nuclear energy program? Please, short message for us. Whether Jean first or Jean-Philippe.
Well, I would say from the institution point of view, why not? And I am not aware of any, but it may be that through the embassy, some cooperation were started. I usually understand that embassy promotes students to come to Europe and perform PhD thesis in our country. So this we may check, and I can do it. It's not a big problem. Now, of course, on other basis, I would like to say that, of course, because of the specific geographic aspect of Indonesia, specific studies for mid-sized island may be interesting. Of course, industrials and nuclear advisor among them could, of course, participate either directly with an institution, national institution, or private company to such a development. This is, if you ask me, I will try to check with the embassy what's going on.
Okay, thank you.
Yeah, I mean, I would just add, obviously, we would be, I mean, very keen to cooperate. And, you know, many countries and many developers are looking at Indonesia quite a lot because, you know, the numbers are clear. We are a very large country with a very big population. The electricity needs are going to grow in the future. And today you are so much reliant on coal. So you know, something will have to happen as I would say the climate pressure increases. And of course, you are a developing country. You need more energy and more electricity to increase your living standards and all that. So we believe that the nuclear option will come on the table sooner or later. We would be happy if it was sooner. We are waiting for a kind of a clear decision of your government in this respect. We hear positive signals, and you mentioned some, Pak Jarod, but there should be a clear plan and program, you know, very clearly set. And of course, if that happens, you can be sure that you will have all the vendors and everyone very keen to cooperate or to propose their products and services to Indonesia. I think Indonesia is in a way unique also in the sense that you will probably need both. You will need the large size nuclear power plants for islands like Java, for example. But of course, on the smaller islands, the SMRs could be a perfect solution. And well, I don't have all the numbers, but I think if we put aside geothermal energy, of which I'm also a great fan, and which you should continue to develop. But I think in terms of renewable resources, Indonesia with its geographic position and all that, you are not in the, let's say, best possible position. So you have some limitations to those resources. So you will have an equation to solve if the equation is to get out of fossil fuels.
Okay, thank you very much. So thank you for the speakers, Pak Jan Barta and Jean-Philippe Girard, for, well, it's very impressive explanation about the situation in France and Europe as a whole. So you have several graph about the situation over there. So hopefully the audience in Indonesia will understand that we need nuclear energy because we have the same challenge, the climate change.
Exactly.
I remember recently the government informed us that we will not build new coal power plant. So this is a good news for the nuclear community, and the government already have a target for the net zero emission in 2060. So again, this is the opportunity for the nuclear energy to be implemented here. And I expect also, because France have a long experience on the nuclear technology, nuclear energy, not only on the reactor, but also on the nuclear fuel cycle and other things also. We may, well, I expect more than we may, but we can have a more good cooperation on that. Again, thank you very much. And I would like to thank also to all the participants. At the peak time, we have more than 450 participants. It's very huge participants. And terima kasih Bapak Ibu sekalian. Kita ketemu minggu depan pada hari Kamis. Terima kasih. Thank you.
Thank you very much.
Terima kasih Prof. Jarod.
Merci bien.
Terima kasih Prof. Jarod.
Terima kasih.
Terima kasih.
Thank you.
Terima kasih.
Thank you
very much.
Terima kasih banyak.
You next in Grenoble.
Terima kasih.
Terima kasih Pak Jarod.
Sama-sama.
Terima kasih.
Ya.
Merci.
Pak Jarod, terima kasih.
Terima kasih Pak Jarod.
Terima kasih.
Terima kasih. Oh Pak Petrus.
Hebat. Mantap Pak.
Ya.
Terima kasih Pak Jarod.
Ya.
Sama-sama. Merci beaucoup.
Merci beaucoup.
Salam kenal dari Lombok. Bapak, makasih.
Terima kasih.
Big thanks, sir.
Thank you.
Well, saya akan menutup Zoom. I will close the Zoom. Anyway, thank you very much again.
Thank you, Pak Jarod.
See you next
and
time.
Keep in touch, huh?